Alright, so here's the third problem we're going to work. Applications of quadratic functions. So it says a ball is thrown upward and outward from a height of 6 feet. The height of the ball, f of x, in feet can be modeled by this function here. So the f of x represents the height of the ball, where x is the ball's horizontal distance in feet from where it was thrown. What is the maximum height of the ball and how far from where it was thrown does it occur? Alright, so let's answer part A first. So I think what we'll need to do here is maybe just draw a little sketch of this. Alright, so if we draw this, so we can draw a little bit straighter line. Alright, so we know at 0, when x is 0, if we plug 0 into here, we'll get 6. Okay, so, and this is the 6 feet. Okay, because if you remember, it says a ball is thrown upward and outward from a height of 6 feet. Okay, so this is our 6 feet right here. Now, it's thrown upward and outward. Now, it's modeled by this function, and the function is a parabola, and we know a parabola looks something like this. Okay, so we want to find the maximum height. Well, the maximum height of the ball is right here. Okay, and then also it wants to find the maximum height of the ball and how far from where it was thrown does it occur. So how far from where we threw it does that maximum height occur? So that's this distance from here to here. So if you look at this, we just need to find the vertex. So if you remember how to find the vertex of a parabola in this form, okay, so to find the x coordinate, okay, that would be this distance here, that's minus b over 2a, where b is the number in front of x, and that's b, and a is the number in front of x squared. Okay, alright, so here we have negative 2.4 over 2 times a, which is negative 0.8, and this equals 1.5. Okay, so this x value here is 1.5. Now we need to find the y coordinate of the vertex. So to find the y coordinate, we just take the 1.5 and plug it in for x. So f of 1.5 is equal to negative 0.8 times 1.5 squared plus 2.4 times 1.5 plus 6. And so f of 1.5 is equal to, and punch that into your calculator, and we get 7.8. So this y value is 7.8. Alright, so the maximum height, so the max height is equal to 7.8 feet, and the distance from where it was thrown, we'll call that, let's just call that x. So x is equal to 1.5 feet, and so this is our answer to part A. Alright, so now it wants to know how far does the ball travel horizontally before hitting the ground. So how far does it travel horizontally before it hits the ground? Well, here's where it hits the ground. So we need to know the distance from here to here. Okay, so basically what we want to know is where does our function equal 0. See, because this is a y value of 0 here. So what we need to do is set our function equal to 0 and solve. And so for part B, this is part B, and this was part A up here. So that's going to be negative 0.8 x squared plus 2.4x plus 6 equals 0. Alright, so to solve this, well, might have a hard time factoring this, so we'll throw it into the quadratic formula. So x is negative b plus or minus square root b squared minus 4ac all over 2a. Alright, so remember, for the quadratic formula, the number in front of x squared, that's a, the number in front of x is b, and our constant term is c. So let's plug that in, and so we get x is equal to negative 2.4 plus or minus the square root of 2.4 squared minus 4 times a times c, and that's all over 2 times a. Alright, so we'll need to put this into our calculator. We get negative 2.4 plus or minus the square root. Now punch this into your calculator, and after putting this into our calculator, we get 24.96 over 2 times negative 0.8, which is negative 1.6. Alright, so we get x equals negative 2.4 plus the square root of 24.96 over negative 1.6, or x equals negative 2.4 minus the square root of 24.96 over negative 1.6. And so x is equal to, so we'll need to put this into our calculator. Okay, so for our first answer we get negative 1.6, and we'll round it to one decimal place, negative 1.6, or x equals, and then we punch this one into our calculator, and we get 4.6. Alright, so let's take a look at these two answers. We get negative 1.6 and 4.6. Well, if you look at our graph up here, you see this would continue on this way, and this is the negative 1.6. So we know this is not our answer here. Okay, this would be the 4.6 where it hits the ground. So that's the distance from here to here. Okay, and I guess we can call that we'll call it D for distance. Okay, so we see that D is equal to 4.6 feet, because this one won't work. This is our answer. Alright, so I hope that helped. Don't forget to like and subscribe. Alright, thanks.